Okay, so this week we are focusing on solving linear equations doing more than one step. So last week we were learning the different properties of linear equations and looking at simplifying expressions with variables and then solving one-step equations basically. Now we're looking at solving when there's more than one step. And so there's like a whole procedure to go on, just lots of different variations. So when you're going through this, you don't want to say, okay, I've seen one exactly like this, because there are like infinite ways that you can see a linear equation. What you want to focus on is the steps, the procedure, because you're not ever going to get an example of every single possible way you could do this. So it's the procedure that's most important, not what it looks like initially. So just as a refresher, when we're talking about linear equations, we are talking about equations that have no exponents on the variable. And so these are called first degree equations. And we're looking at ones that just have one variable. So later in the class, near the end, we will look at two variable linear equations, which you graph versus solving. So if you've got one variable, you are solving. And generally, we want to try to write these equations in the form ax plus b equals c, if possible. And then we kind of narrow it down from there. And that's where you've got some number in front of your variable, and then you may have a number added or subtracted after that, and then it equals another number. But that's like the most basic form, and that's like a two-step equation. And these could take more than two steps. It depends on how it looks. So we're kind of work our way up in difficulty, or at least as far as the number of steps you're doing. So when we are solving, that specifically means we're trying to find the value for the variable, the number that makes the equation true. So this is called the solution. And we write this as a solution set. So if you see the phrase solution set, like in Connect Math, that's saying that they want the number inside the curly braces, because those braces are used to indicate a set. So you would just put whatever your answer is inside there. If it doesn't say solution set, then you could write like the equation x equals and then the number. So you do have to kind of pay attention to the language so that you know how the answer is supposed to be written. If we have an equation that has no numbers that make it true, then we say there's no solutions. And if we have an equation where more than one number can make it true, or if any number, like you could have two numbers that make something true. When we have linear inequalities, you're not going to get just two numbers. You're either going to get one answer that makes it true, no answer that makes it true, or any number works. So if all values make it true, then we say there's infinite solutions, or that our solution set is all real numbers. I don't believe I've picked out any that are going to be the no solution or all real number solution. I try to be very careful to make sure that each one that I've picked has a solution, though I may have maybe done that wrong if I mistyped a number, but I was trying to make sure that we don't have any of those, just so you can focus on ones that actually do have a solution.
I have a question, Professor.
Mm-hmm.
Okay, so how do I upload I have a screenshot here of my question. How do I upload that to you, or to this?
If you were asking about a specific equation, that would be best to be emailed to me, because I'm focused
Okay.
at just talking, if it's like a homework question or something like that, everybody has different questions. And so that's more of a email while I'm going, since I want to focus on the process here and showing you examples of how to solve these.
Okay, so my question has to do with your slide here. In the video that you had posted on Khan Academy, as Sal was talking about this, he had a solution for infinite solutions. He had an equation with no solutions, and then he had an equation with one solution. My question being is why, and I can email it to you as well, why is it that on two of them, he works on, getting the variable to one side and then, doing the adding, subtracting, multiplying, dividing of the numbers. And then on one of them, he starts working with the variables first.
Okay.
And doesn't do anything with the numbers.
So yeah, so that is because you're asking about a specific video, that is something that should be emailed to me.
Okay.
And then make sure you tell me which specific video so I can review the video and know exactly what point you're talking about.
And that's fine. And I say, and that's why I say, because, my question being is why is it on infinite solutions, you do it one way, and then, one solutions, you do it the same way. No solutions, you do it differently. I guess what
Yeah.
What is the determining factor?
I need to see the exact situation to answer that question, because there is there is.
I got you. I got you.
Yeah, because if you
follow,
there's not like you do it this way and then you do it this way if it's a different solution. I imagine that it's based off of what he was looking at and he decided to solve it differently. So
okay.
That
was my question.
Yeah, so that is currently outside of what I am talking about today, because I'm going to focus on ones that have solutions, not these other cases.
Got it. Thank you.
Yep. Okay, so in order to solve, we have two properties that we use. And looks like I forgot to add a slide for the multiplication and division properties of equality as I'm looking at this here. So we've got the addition and subtraction properties. So that is where the addition means you can add the same number on both sides. Subtraction property means you can subtract the same number on both sides. And then the slide that I've forgotten to add in, I meant to grab it, is multiplication and division properties of equality, where you can multiply the same thing on both sides or divide the same thing on both sides. So, but when I post the PowerPoint after this, I will add that slide in. But those are the properties that we learned about last week that we will be using to solve. So what we're focusing on this week is how to use both of those, all of these properties to solve when you've got more than one step. So this is the procedure that you want to follow every time you are solving a linear equation. And if you follow this procedure, it doesn't matter what the equation looks like. This is what you do. So you really want to focus on the steps, not what the equation itself looks like. So the first step is you need to simplify both sides of the equation. So simplify the left side of the equal sign and then the right side. And you follow the order of operations. You're simplifying that side. So if there's anything that you need to distribute, you do that. And then you combine any like terms. And then that will either get you down to something with a variable plus a number, or you might have just a number, or you might have just a variable, but you're not going to have more than two terms on either side. Then you're going to use the addition and subtraction properties of equality. So that's always the next step. So I generally move my variables first and then my numbers, though the order here doesn't matter. And it doesn't matter whether you move your variable to the left or the right, or which side you put it on, but I always try to put mine on the left and then the number on the right. And I do it that way because when you're solving inequalities, which is something you'll do in week 7 or week 8, you have to have the variable on the left. So because there is a specific type where you have to have the variable on the left, I just try to be consistent and do the same thing when I'm solving an equation, is I put the variable on the left and then the number needs to be on the right. Once you've done that, so you've got your variable on one side, number on the other side, then you're using the multiplication or division properties of equality. So if you have a fraction in front of your variable, then you're going to multiply both sides by the reciprocal of that. And if it's not a fraction, so it's an integer, a whole number, positive or negative, then you're going to divide both sides by that number. And then that will give you your final answer. So it's 3 basic steps, but there's kind of sub steps that you do inside each steps. But that's the procedure. That's what you do every single time. So we're going to start with this one, which is in the form ax plus b equals c. This is a 2-step equation. We're going to solve it, and then we're also going to check your work. So whenever you're solving, you can always know whether your answer is correct by checking your answer. So there's no solving and then being like, well, I don't know if that's right, because you can always find out if it's right, assuming that you make no errors in checking your answer. So first we will start with solving. So I start with my equation, which is 5x plus 2 equals 13. So first step is to simplify both sides. So this is something that you do if you have parentheses, meaning you have to distribute, or if you have more than 2 terms and there's nothing, you can combine things. So on the left, we cannot combine the 5x plus 2 because one has a variable, one doesn't. And then on the right, it's just a single number. So we can skip the first step where you're simplifying both sides because that's already done. So then our next step is we always add or subtract. So I always start with the variable. If I have the variable only on one side, that's what I want. So then I'm done moving the variable and I look at the numbers. So I've got numbers on both sides, constants without variables. I've got a plus 2 on the left and then the 13 on the right. You always want to move the number away from the variable. So if our variable is on the left, then I want the numbers to be on the right, the constants. So I have to move the plus 2. I have to remove that from the left and move it to the right. And we do that by doing the opposite of the sign. So if it says plus, then I'm going to minus. So that is our first step here, is I'm going to subtract 2. And every time we solve an equation, we work vertically. We're always going from top to bottom. We never go sideways. So you want to make sure you're writing it like I am doing here. And so we get 5x. The 2 minus 2 becomes 0, so that's no longer there. I don't need to write it. And then 13 minus 2 is 11. So I end up with 5x equals, oops, and I wrote my equation wrong. That's a negative 13. So negative 13 minus 2, negative 15. So always make sure you write your equation down correctly. If you don't, that's where you could commonly make mistakes. And if I do that in the future, if you catch that, let me know. So that should have been a negative 13. So then negative 13 minus 2, that's negative 15. So we end up with 5x equals negative 15. Once you have your variable equals a number, something with a variable equals number, then you're done with your adding and subtracting because we just have one thing equals one thing. And that's where you move on to either multiplying or dividing. So you multiply if you're going to have a fraction in front of the variable, otherwise we divide. So we've got a whole number, 5, in front of our variable, so we're going to divide. And you divide by that number that's in front of the variable because we want just the x by itself. We don't want 5x, we want just x. So we're going to divide both sides by 5. And we always write it as a fraction because sometimes when you do this step, fractions get created and your answer is a fraction. We never write our answer as decimals unless you have decimals in your original problem. So since we don't have any decimals in the original problem, we're going to be writing this as a fraction if it's a fraction, otherwise whole numbers if it reduces. But we always write this step as creating fractions when we do that division. So 5 divided by 5 is 1, and we don't need to write the 1. We can just write x. It's assumed to be a 1x if you just have the x by itself. And then on the right, we do negative 15 divided by 5, and that gives us negative 3. So once you have your variable with no number in front equal to a number, that's your answer. So we have x is equal to negative 3. So this was 2 steps. We had to subtract 2 from both sides, and then we divided by 5 on both sides. Now to check your answer, you go back to your original problem, 5x plus 2 equals negative 13, and you are replacing the variable x with what it's equal to, negative 3. And then you're going to follow the order of operations on both sides, or try to simplify both sides and make sure that your left side is equal to the right side. So that's 5 times x. So now that's going to be 5 times negative 3 because x is equal to negative 3. So we have 5 times negative 3 plus 2 equals negative 13. Now, the right side, there's nothing I can do there, but on the left side, I want to follow the order of operations. So we multiply first. 5 times negative 3 is negative 15 plus 2 equals negative 13. Then I need to add negative 15 plus 2, which is equal to negative 13. So I get negative 13 is equal to negative 13. So when the left side equals the right side, that is a check. Your equation is true. That means that this is the correct answer. So if you were checking and you got something that's not true, like had I not initially noticed that it was supposed to be negative 13 and it was supposed to be 13, and then I wrote it with negative 13 later or something, I would get the left side and the right side not matching. And then that would indicate that I made a mistake somewhere. So you can always check your answer, assuming that you wrote your equation correctly both times. So if there are any questions on this example? Okay. So now let's do one with fractions. And I strongly recommend that when you do problems with fractions, you have a calculator that can do fractions, and use your calculator to do the fraction part because it will just make your life easier. So we are solving 6/7 equals 1/7 plus 5/3 times r. So step 1 is to try to simplify each side. So the left side is a single number that's simplified. The right side is also simplified because I cannot combine those like terms because one has a variable, one doesn't. So step 1 of solving is done. Step 2 is where we add or subtract. So I always start with my variable. If the variable is on one side, then I just leave it there. So in this case, our variable is on the right. So I'm going to solve it and keep my variable on the right. So I'm not going to move it to the left because that will be extra work. This will be one case where I'll keep it on the right. So since I want my variable on the right, that means the numbers have to be on the left. So that 1/7 I have to move away. It needs to be on the left side, not the right side. So it's a positive 1/7. So to move it, we subtract 1/7. And so in order to do this, you have to make sure that your fractions have a common denominator. So on the left, we have 6/7 minus 1/7. So there's a common denominator. So we can subtract 6 minus 1, which is 5, and we get 5/7. If there was not a common denominator, then you would have to get a common denominator to do the subtraction. Or if you use your calculator and it does fractions, you can do that on the calculator and then it will give you the final answer. So in this case, common denominator, so we can just subtract. We get 5/7 equals 5/3 r. So once you have one thing equals one thing, you're done with step 2, which is the adding and subtracting, and now you're moving on to multiplication and division. So we have a fraction in front of our variable. So this is where we're going to multiply both sides by the reciprocal of that fraction. So we want to get rid of the 5/3. We multiply by the reciprocal, which would be 3/5, and we do this on both sides. So always write your multiplication with a dot. We do not use the letter X because that is a variable. So we use a dot. So now I'm multiplying both sides, and that will allow my fraction to cancel out on the right, basically. I have a 3 on top, 3 on the bottom, 5 on top, 5 on the bottom, those cancel. On the left, my 5s will cancel. And so when I multiply, I always try to simplify first and then multiply. That gives me 3/7 equals R. So if with that multiplication step, if you have a calculator that does fractions, you can also use your calculator to do that. And then that saves you some time and you can get the answer from your calculator. When you have a problem with fractions, you keep everything in fractions. You don't try to convert them into decimals or anything. So your answer is either going to stay a fraction or it's going to be like a whole number. So we have 3/7 here equals R. So to check our work, we go back to our original problem. 6/7 equals 1/7 plus 5/3 R. And you replace R with our answer 3/7. And so I'm just going to label this check. Left side, there's nothing we can do, but now we're following the order of operation on the right. So we need to multiply those fractions. So the 3's cancel out there. And so we get 6/7 equals 1/7 plus 5/7. And then when I add 1/7 plus 5/7, that gives me 6/7. So I get 6/7 equals 6/7. And then, so I've checked, my answer works. So that is our correct answer, 3/7. Any questions? Okay. So now I'm going to start putting 2 problems on each slide, and we're not going to check. We're going to just solve these. So on the left, we have 4v minus 3 minus 5v equals 13. And then on the right, we have 11h minus 8 minus 9h equals 16. So we'll start with the one on the left. So we have 4v, and this is a capital V. Capitalization matters when you're answering, when you're typing into Connect Math or even just writing your letters. So you want to make sure if it's capital, it stays capital. If it's lowercase, it stays lowercase, because changing the case of a variable actually means it's a different variable. So I have to make sure that I keep these as capital V's because that's how it's written. So our first step is to simplify both sides. And so on the left side, we have 3 terms, and we can combine our like terms because we have a negative, or we have a 4v right here and a minus 5v. So I can combine those like terms. So I'm going to simplify, do that first. So 4 minus 5 is a -1. So I get -1v. Then I have my minus 3 equals 13. So I had to simplify and combine like terms on the left before I do anything on both sides. So now left side is simplified, right side simplified. So now we're doing addition and subtraction. So I've got my variable only on one side and I want to keep it that way. So I'm going to keep my variable on the left because that's where it's at, which means I have to move that -3. So I need to add the 3. I need to do the opposite. So I'm going to add 3 to both sides. So that gives me -1v equals 16. 13 plus 3 gives me 16. Now that I have one thing equals one thing, that's where I move to multiplication or division. So we don't have a fraction, which means we're going to divide. And we always want a positive v. So if you had a negative v or a -1v, you want to make it positive. So we have to divide both sides by -1 because we want our positive variable, not a negative variable. So I'm going to divide both sides by -1. And that gives me v equals a -16. And so that is my final answer. So now the one on the right is set up very similarly. You can see it's got different letters, different numbers, but it's basically the same setup. So you're going to be doing it the same sort of way. We have 11h minus 8 minus 9h equals 16. And I do encourage you when you're doing your stuff on paper to color code like I am, because it can help you keep track of what you're doing. So we need to combine like terms. So I need to do 11h minus 9h. So 11 minus 9 is 2. So we get 2h minus 8 equals 16. So I want to keep my h on the left. So I'm going to move the -8. So now I'm going to add 8 to both sides. We always do the opposite. So that's 2h equals, and then 16 plus 8 is 24. And then now that we've one term equals one term, we need to get rid of the 2 in front of the h. So I'm going to divide by the 2 because it's multiplied. So I divide both sides by 2, and this gives me h is equal to 12. Are there any questions on either of these two examples?
I have one, Professor.
Okay.
Will you ever have, like in the first one, will you ever have a variable, a negative variable? Or is it, do you need to always make it positive?
Your final answer, you always need to have the variable positive.
Okay.
So because I had a negative in front of my b, I had to divide by a -1 to make it a positive b.
Right. No, I understand that. I didn't know if if this was just something as part of, the pre-algebra, hey, learn it this way, or, is there ever going to be a time where you're going to have a variable as a negative?
So when you say variable as a negative, what are you just meaning your final answer would be like -v?
Correct.
Yeah, you never write your final answer that way. You always write it because we want the value of v. We don't want the value of -v.
Okay. That answers my question. Thank you.
There are other questions. Okay. So now on the left, we've got negative 7t plus 4 equals negative 6t. And then on the right, we have 3a plus 7 equals 5a minus 19. So we'll start with the left. And so I always start by rewriting the equation. Negative 7t plus 4 equals negative 6t. So there's nothing to simplify on the left or the right. They're already simplified. So we move to step 2, which is the variable part. So I have a variable on both sides. So I could choose to move my variable to the left and make the negative 6t be on the left side, and then put the number on the right. Or I can put my variable on the right and keep the number on the left. If one side has only one thing, that kind of drives what you do. So we have only a variable on the right, so it saves us steps if we move the variable to the right side. It will actually be less work. So even though I prefer my variable on the left, it will be less work if I keep my variable on the right. So that means, and I always move my variables first before I do any numbers, because that's kind of like your goal is to get the variable by itself. So that's what I always focus on. So my negative 7t, I'm going to put it on the right side. It's negative, so we're going to add. So we're going to do plus 7t. So that gives me 4 equals, and then negative 6 plus 7, and this is the same as 7 minus 6, that gives you a 1t. So I got 4 equals 1t. Now, if you just have the number 1 in front of your variable, you don't need to write it. You can just write 4 equals t, and we've solved the problem already. We are done. If we have a negative 1, you have to divide by the negative because you want it to be positive. But we have 1t, it's equivalent to regular t. So this basically was a one-step problem. If I had moved my variable from the right to the left, it would have ended up being a 2-step problem. I would have had to do more, or a 3-step problem, actually. It would require more work. So when you're solving, you have to kind of think about what is easiest, what will require less steps, what is the most efficient way to solve. So if you've already got a variable by itself on one side, then put all the variables over there, because that will be less work. Now, the second example here, we have 3a plus 7 equals 5a minus 19. So in this case, both sides are simplified, but we've got variables on both sides. So you can choose whether you want your variable on the left or the variable on the right. And so this is where I always say, I want it to be on the left. So I always do that first. So that means my 5a, I want to move to the left side. So I'm going to subtract because it's positive. So that's going to be a minus 5a. And so I'm subtracting 5a from both sides. So 3 minus 5 is negative 2. So I got negative 2a plus 7 equals negative 19. Once you move your variable, then you move the number. So now that the variable is on the left, I have to move the number to the right. So that plus 7 needs to be on the right. So we have to use the addition or subtraction property again, but this time to move the variable. So I'm going to subtract 7 from both sides. So this gives us negative 2a equals, and then negative 19 minus 7 is negative 26. So if you have variables on both sides and numbers on both sides, you basically have to do the addition or subtraction property twice, because your ultimate goal is to get something equals something, and then that's when you divide or multiply. So now that I have something equals something, I have a negative 2a. I want just a. So I need to get rid of the negative 2. And since that's multiplied, we're going to divide. We're going to divide both sides by negative 2. And so this gives us a equals 13. Since negative 26 divided by negative 2 is a positive 13. So this was a 3-step problem, and we had to use the addition subtraction property twice before we did our division. Are there any questions on either of these two examples? Okay. So now we're going to get into ones where we have to do some distributing, and these are more steps. So now I'm going to do like one example per slide because it is going to be more steps. So we want to solve 6 times 3x plus 2 minus 20 equals negative 4. So when you're taking notes, always make sure that you write down the original problem, including the word solve, because that word solve is telling you what to do. It's telling you you want to find out what the variable is equal to. So you want to write the whole thing, and then I rewrite it so that I can start marking it up and doing my work. So we want to simplify each side. The right is already simplified, but the left, we have some work to do. We need to distribute. That distributing always happens before you combine like terms, because multiplication happens before addition. So I need to multiply the 6 through the parentheses. So 6 times 3x is 18x. Plus 6 times 2 is 12. And then I have my minus 20 equals negative 4. Now I want to add my like terms, which in this case is going to be the 12 and the minus 20. So we're going to do 12 minus 20 in our next step. So I have 18x, and then 12 minus 20 is negative 8. So 18x minus 8 equals negative 4. Now that I've simplified both sides, my variable is on the left side only, so I'm going to keep it on the left. So I'm going to move the minus 8 to the right. So we're going to add 8 to both sides. So we get 18x equals negative 4 plus 8 is equal to 4. Now that we have something equals something, I want to have just x. I need to get rid of the 18 in front. So this is where we divide, and we divide both sides by 18. And we get x equals, and then you have 4 over 18. So that doesn't divide evenly. That would give us a decimal. So this means we're going to write our answer as a fraction. And so we need to reduce that. So I can't divide them both by 4. 4 doesn't go into 18, but I can reduce them both by 2. So 4 divided by 2 is 2. 18 divided by 2 is 9. So x is equal to 2 ninths. So you can do that in your head, or what you can do is first write the fraction you got, 4 over 18. And then show your work to do the reducing. And this is the one place where you can go to the right, because you're not, when you're solving, you're doing things on both sides, so you go vertically. But if you're only doing something on one side, like I am here, which is reducing, I can move to the right horizontally. So then I could show my work for reducing and then say equals 2/9. And then you can just choose to box just that part if you'd like. Other questions? Okay, so here, now again, we're getting more complicated. We have 5 times 4 plus p equals 3 times 3 minus 1. I think I meant to put that as a p. So I think I typed a 1 instead of a p. I'm not sure why. And then minus 9. So we'll just change that to a p. I'm pretty sure that's what I intended. So we need to distribute on both sides before we add our like terms, before we actually start the solving process. So on the left, I need to multiply the 5 by 4 and the 5 by p. So that gives me 5 times 4, which is 20, plus 5 times p is 5p. On the right, you're also going to distribute 3 times 3, and then 3 times a negative p. So 3 times 3 is 9, and then we're going to minus 3 times p is 3p. So we have 9 minus 3p, and then I have a minus 9 here. So left side simplified, right side, we need to simplify further because we have a 9 and a minus 9 that we can combine. So 9 minus 9 is 0. So what happens is that basically is disappearing. And so we have 20 plus 5p equals minus 3p, since the 9 minus 9 is 0. So now we have a situation that's similar to a problem where we did before, where we have the variable on both sides, but one side has the variable by itself. So that's the side we want to move our variable to. So I'm going to move the 5p to the right because I already have the variable by itself on one side. So I'm going to subtract 5p since it's a positive on the left side. So that gives us 20 equals negative 3 minus 5 is negative 8. So we get negative 8p. So now we have a number equals a number. I want to get the p by itself. I don't want that coefficient there. I need to get rid of the negative 8. So we're going to divide both sides by negative 8. And usually at this point, I will just kind of reverse what I have and do p equals instead of doing the number equals p. But it's going to be 20 over negative 8. So 20 divided by negative 8 is a decimal. So again, we're going to leave it as a fraction, and then you want to reduce. So I can divide them both by 4. And when you have a negative, you usually put it in the middle instead of on the top versus the bottom. So we'd have a negative 5 halves as our answer. It's not wrong if you keep your negative in the denominator. We just generally would put it in the middle versus on the top or the bottom when we write our final answer. Any questions? Okay. Would you ever change the 5 halves to a mixed number? That is actually an excellent question. So let me go back to the answer is no. So In algebra, we generally never, ever, ever write answers as mixed numbers. The only time we might do that is with a word problem, but when we're solving, we never use mixed numbers. Converting it to mixed number is more work. We don't need to do it. There is nothing wrong with an improper fraction. And if you try to make it a mixed number, it will actually be marked incorrect in Connect Math. Because we just don't do that when we're solving algebra. It's more work that it's not necessary. So you just leave it as the improper fraction. That's the best way to give your answer. Okay, so here, this one's a very interesting looking one. But we're gonna follow the steps that we know, and this is going to take several steps. So I'm going to end up doing 2 columns here because it is going to be a longer one here. So we've got t equals 2 minus 2, and then brackets 2y minus 3, parentheses 1 minus t. So because I know that this is going to be longer, I'm going to move this to the left so I can have 2 columns. And brackets and parentheses are basically the same thing. So if you want, you can just convert your brackets to parentheses. And I just make them a little bigger, just so I can kind of see the difference there. So left side is simplified. Right side is not. So we have to simplify the right side. So this is why we had to go through how to simplify expressions, because that's what we're doing here on the right. So when you've got multiple sets of parentheses, you start inside out. So I need to distribute the inside set before I go to the outside set here. So I have this minus 3 that I need to multiply through. And if it helps, you can convert a minus 3 to plus a negative 3 to make sure that you're doing your distributing correctly. And instead of 1 minus t, you can write that as 1 plus a negative t, just to make sure if you tend to make sign errors that you don't have mistakes there. So I have t, and I always curve my t's so they don't let, that's a typo. Instead of y, this should have been t, because we're supposed to have one variable, and I have t's everywhere else. So apparently for whatever reason, I wrote a y. That should be a t. With the T and the Y right next to each other in the keyboard. So I just hit the wrong button. So I always write my T's curved so they don't look like plus signs. So I've got T minus 2 parenthesis 2T. And then I have negative 3 times 1. So that's going to be negative 3. And then negative 3 times negative T. The 2 negatives cancel. That's going to give you a positive T. So you have 2t plus negative 3 plus 3t inside in the parentheses. And we need to simplify the like terms before we distribute again, because we're still working inside the parentheses. You work inside out. So I can add the 2t plus 3t. So if t equals 2 minus 2 parentheses 2t plus 3t is 5t. And then I'm going to just write minus 3. So now we've simplified inside the parentheses. Now we need to distribute. So that's multiplication. So we took care of the parentheses. Now we're distributing. And again, if it helps, you can put plus signs before these minus signs, because you're really multiplying by negatives here. So we have t equals 2 plus, then I have a negative 2 times 5t. So that gives me a negative 10t. And a negative 2 times a negative 3 is a positive 6. So now I need to combine like terms again. And that is going to be the 2 and the plus 6 here. So I've got t equals 2 plus 6 is 8. And then I can just write that as minus 10t. So we have t equals 8 minus 10t. So now I'm done with simplifying. I've simplified the left, I've simplified the right. So that first step in the solving process where you're simplifying could be multiple steps as you're working through to simplify everything. So there could be lots of things that you're doing. You're just going through your order of operations and going through, what you know to get down to basically two terms. Now I've got a t on both sides, but the left side has the t by itself. So I'm going to move the t's to the left. So I'm going to add 10t to both sides. And so that gives me 11t equals 8. And so, like I said, I knew I was going to kind of running out of room. So normally if you do this on a piece of paper, you just keep going. But since I am limited by how much space I have on my PowerPoint, I'm going to just move an arrow so I know where I'm going next and then just make a second column here. So we have 11t equals 8. And so our last step is to divide both sides by 11. So that gives me a final answer of t equals 8 over 11 because we don't want to give it as a decimal, and 8 over 11 does not reduce. So that's your final answer. There are questions? Okay, so I've got one more example. And again, you can see how you can get pretty long problems here because you've got a lot of simplifying to do, but it all boils down to the same steps at the very end. So it's just a matter of following the order of operations, doing your simplifying in the correct order as you go. So again, I'm going to need multiple columns here. So I've got 5 minus, and then parentheses 6k plus 1. So if you see a minus in front of parentheses and there's no number there, I always recommend that you change that to 5 plus -1 times. So the minus parentheses is the same as -1 parentheses. And then I always just change it to plus a -1 just to help eliminate any possible errors in signs. So now we've got 2 and a bracket again, which if you want, you can change it to parentheses. And then if you have a set of parentheses without a number in front, so we've got the bracket and then parentheses, there's no number in between there. If there's no minus sign in there, that means that you actually don't need those. So that means I can just eliminate that, the 5k minus 3. And you may be wondering, well, why were they put in there? It's just sometimes it makes it a bit easier to read. Oops, so that means I don't need that parenthesis. Then again, I have this minus and then parentheses. So when I see that, I change it to plus -1 and then parentheses k minus 2. And then I end my brackets with my bigger parentheses. So sometimes I rewrite what I've given just to make it a little bit easier. So now we need to simplify both sides. We have the left side we're simplifying, the right side that we're simplifying. And we don't have to be at the same step as we simplify each side. So on the left side, when I simplify, I need to distribute. So I need to multiply that -1 through the parentheses. So I have 5, and then a -1 times 6 is a -6, so it's going to be minus 6k. And then a -1 times 1 is -1. Now on the right side, when we're simplifying, when you have multiple sets of parentheses, you work inside out. So I still am distributing, but I need to distribute the inside parentheses first. So the -1 times the k minus 2. So I have 2 parentheses 5k minus 3. And then -1 times k is negative k or minus 1k. -1 times -2 is a positive 2. So now next we're simplifying. On the left side, when we're simplifying, we can add our like terms, 5 minus 1. So 5 minus 1 is 4. So I have 4 minus 6k. Now on the right, we're simplifying in the parentheses. So I've got a 5k minus k that I can simplify. But we can also simplify -3 plus 2. So I'm just color coding those separately because we can simplify both of those and combine those like terms. So 5k minus k, that's 5 minus 1, so that's going to be a 4k. And then -3 plus 2 is a -1. So that's going to be written as -1 there. Now, left side is simplified. There's nothing more we can do on the left, but the right side we can still distribute. So we're still simplifying. We're not even solving yet. We're just rewriting these. So I get 4 minus 6k equals, and then 2 times 4 is 8, so that's 8k. And then 2 times -1 is -2. So now we're down to where we have 2 things equal 2 things. We've simplified both sides. Now what we're doing is actually the solving part. What we were doing before was just simplifying. Now we can solve by doing things on both sides. So I always move my variables first. And I've got variables on both sides, so I'm going to just move it to the left. So that means my 8k on the right, I'm going to move to the left by subtracting 8k. So I got 4, and then -6 minus 8 is -14k, and then that equals -2. So now I've got my variable on the left, but I've still got a number, a constant on that same side that I moved to the right. So that 4 needs to be on the right side now. So I'm going to subtract 4. And then, as predicted, I'm running out of room. So 4 minus 4 is 0. We're going to get a -14k equals -6. -2 minus 4 is -6. So now that I've done my addition and subtraction, you should only do this step once or twice. You never need to do it a third time if you simplified all the way. So now is our division step. I need to divide both sides by -14. So that gives me k equals, and so I have a negative divided by negative, which gives me a positive, and we get 6/14, which needs to be reduced. So I can divide those both by 2. And that gives me 3/7. So our final answer is 3/7. So it's a lengthy process. You have to be very methodical. Make sure that, like, for the first part, when you're simplifying, you're following the order of operations, combining like terms, going through that process. And then you get to a point where then you start doing the adding or subtracting, and then the multiplying or dividing is always your very final step. So you see the process that you go through. It's the same process over and over and over again. So once you know the process, it doesn't matter what your equation looks like. You can solve it as long as you're following that process. Are there any questions? Okay, so that is how you solve when you have more than one step, basically. And the best way to get good at this is just to practice and do a wide variety of problems so you can practice that procedure. And the key to learning algebra is to learn the procedures, not what a particular equation looks like, but to learn the steps, because you just follow the steps every time. And as long as you know the steps, you can deal with pretty much any type of problem. So really focus on that procedure when you're solving. Do lots of practice and you'll start to kind of get this, and it'll be soon natural, and then everything going forward will start getting easier as well.